Well, hello everybody. Welcome. Today I want to talk about advanced completing the square. So get some writing materials because thinking and writing go best when they go together. Okay, so a bit of review before we get into the details. Completing the square means that we're going to be creating a perfect square trinomial and then factoring it down. So if you will recall, there's a special factor pattern where if you have a squared plus or minus 2ab plus b squared, that factors down into a plus or minus b quantity squared. The key thing to pay attention here, though, is that 2. We're going to have to manufacture double something, and so that 2 is going to be involved. So keep your mind on that. And also, standard form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are coefficients or constants, and it's written in descending degree of x. There's an x squared. The b term is x to the first, although that's a newbie mistake. You probably shouldn't write that. And then c is x to the 0, but nobody ever writes that, not even newbies. So we're going to need the quadratics in that form. And what we want to do is we want to get these down to this format. We want it to be a times x minus an h is just the number, squared, and then I'm going to say plus d. D is just the next letter in the alphabet after C, and it just represents some constant number. You may be familiar with a K, but sooner or later you're going to be completing the square with a group of X's and then simultaneously completing another square with the Y terms. You're going to be doing 2 of them at once, maybe someday even 3 of them at once. And so the K as a constant is associated with the Y group. So I don't want to use that here because if you see it then later, you'll be confused with this here, and it's not the same thing. So I picked the next letter in the alphabet, B. All right, so this is advanced, so I'm going to assume that you already know how to complete the square for easy ones, and we're going to jump right into sort of a more complicated one, but this is still just an easy one. You probably should have done this on part 1 of completing the square. Let's say that I had x squared plus 5/6 x minus 2. All right, so again, I want to get it in the form where it looks like that. It's got a binomial that's squared. So what I'm going to do first is I'm going to group the x squared and the x term. The -2 there is not part of the group. And so on the next line, I will open up my group and I will say, all right, x squared plus 5/6 x, leave space in the group because somebody's going to be joining the group, minus 2 over here. Now what I have to do is take half of the b term, which is 5/6, and maybe I'll do that kind of off to the side over here. Oh, 5/6, and then I have to divide that by 2. And don't panic, whenever you divide a fraction by 2, you're just going to wind up putting 2 in the denominator with the 6 as a multiplier. So this really is equal to 5/12, and then I have to square that. So what do I add inside the group to complete the square? I'm going to add in 25 over 144. It's so gross. And then if I'm going to add in 25 over 144 inside the group, what do I have to do outside the group? I have to subtract off 25 over 144. You're going to say, no, Mr. Marsh, you got that wrong. Whatever you do to one side of the equation, you do to the other side. So you're going to add in 25 over 144. And I'm going to say, no, you're mistaken. Not on what you said. What you said was true, but this is not an equation. This is an expression. You can't add the same thing to both sides of something when there isn't both sides. There is no 2 sides. There's just one side. In fact, can you even have one side if there's not another side? I don't know about that. There's no equal sign here. So in the end, what I have to do is I have to add in I have to add 0. So I do a plus 25 over 144 in the group, and then a minus 25 over 144 outside the group. So the total I've added in and out of the group is 0. The value didn't change, even though its structure did. Okay, so now the thing inside the parentheses is a perfect square trinomial. So now this factors down into x plus 5/12 squared, because it's either the square root of this or half of that, because this one has to be double. Remember the 2 from the previous one? Whatever this is here, it's going to be double the thing that goes with the x down there, the root. All right, now I got to clean up this minus 2 minus 25 over 144. Fractions have to have a common denominator. Don't panic. This one just has to have a common denominator of 144. How do I do 2 over 1 with a common denominator of 144? Well, that would be double 144. I guess that's double gross. Okay, so that's minus 2, what, 88? And so I need to now combine these right here. This is now going to be minus, what do we get? 313 over 144. There we go. That's in the form now I want it. Okay, good. I've completed the square and I've made it a binomial squared, and then plus or minus something afterwards. Good, that's what I wanted. All right, let's do now a more challenging one. Let's do 3x squared plus 12x minus 7. What are you doing? The coefficient on the x squared term is not 1. Well, you have to factor it out. So I'm going to be grouping these together. Negative 7 is not part of the group. So I need to give myself a little more room because I'm going to be adding something to the group. So the 3 comes out front. Factor a 3 out of x squared. Well, that's just x squared. 3x squared. And then factor a 3 out of 12x. Well, that's plus 4x. And now, what do I have to add inside the group to complete that square? Well, what's half of 4? 2. What's 2 squared? 4. So I'm going to add 4 inside the group. And if I add 4 inside the group, let me go ahead and carry on through here with my negative 7. If I add 4 inside the group, what do I have to subtract off to be sure that I've added 0? 12. You're going to say what? Yeah, well, I added 4 inside the group, but in the end, it's going to be multiplied by this 3 that's out front here. So what did I really add in? I really added in 3 times 4, which is 12. So I have to then subtract off whatever I totally added in. So yeah, I have to subtract off 12. So now this factors down to, it's going to be 3 times x plus 2 quantity squared, and then combine those two, negative 19. There we go. Ta-da! Pretty good, eh? Now, let's put these two examples together into a third, kind of a hybrid. You'll see what I mean here. Let's do this. Let's do 2x squared minus 7x plus 5. You say, oh no, that's so easy. Okay, you got to group those together. Leave space. Factor out the 2. Okay. 2x squared there. Oh, wait. Oh, my goodness. How do I factor a 2 out of 7? You're going to say, you can't. And I'm going to say, you're wrong. But it's not going to be an integer. It's not going to be a whole number. It's really kind of simple. Let's think the process through backwards. Whatever number I put in here, if I multiply it by the 2 that's out front, it has to equal 7. What times 2 is 7? How about minus 7/2 x? Think about that. Isn't 2 times 7/2 7? Yeah, so anytime that you want to factor something out of a number and it's not an integer factor, all you have to do is leave what remains as the thing divided by whatever you factored out. So how do I factor a 2 out of 7? What remains? A 7 over 2. because when I multiply them together, the 2's got to drop out. Just leave me 7. Okay, nice. All right, so now we got a plus 5 over here. All right, now here's the hard part. You thought that was the hard part. Here's the hard part. The hard part is I've got to take half of 7 halves, square it, and add it in. Okay, so over here on the side, half of 7 halves. There's 7 halves divided by 2. We said, no, just multiply the denominator by 2 if you're going to divide a fraction by 2. So that equals then 7 over 4. And then I have to then square this. And so what I'm really adding in here, I'm adding in 49/16. Okay, so let me get rid of this simple work here. Now, if I'm adding in 49/16 inside the group, what am I subtracting off over here so that I've added in nothing? And hopefully now at this point, you see that you would subtract off 49/8 because it's going to be the 2 times that 16 there. Okay, let's clean it up. 2 times x minus 7/4 squared. Right? It's always the square root of what you added in. The square root of 49/16 is 7/4, or it's half of the b term. 7 over 2 divided by 2 is 7/4. All right, so now I gotta turn this into an 8. So how do I do 5 over 8? Isn't that going to be a 40? Right? So it's going to be a positive 48 minus 49/8, and so in the end I'm going to get minus 9/8. There we go. See, it's actually not that hard. You just got to put a bunch of little pieces together. All right, so now let's do the one that you maybe have been anxious for. You're like, oh, I don't like this fraction stuff. I want to be able to use my calculator. Okay, here we go. So let's do x squared minus 2.6x minus 5.12. Okay, I'm going to group these together. So the coefficient on x squared is 1. I don't have to factor anything out. X squared minus 2.6x, leave space, minus 5.12. Somebody's going to join the group. Who's going to join the group? Well, I have to take half of 2.6, and I'll get my machine now. 2.6 divided by 2 equals, oh yeah, 1.3. And then square that. Do you know what that is? You kind of should. It's just 13 squared with the decimal managed. This is going to be plus 1.69, and then this is plus. No, wait, I have to subtract off. Oh yeah, I almost thought it was an equation, but it's not. Minus 1.69. And so in the end, now this factors down to x minus 1.3 squared minus 6.81. Ta-da! Pretty good, eh? May your days be merry and bright, and may all your mathematics be right.